In the first part of this talk, I described and discussed modes of explanation from classical times to the Hempel and Oppenheim article on the covering law model of explanation, which appeared in 1948. In this talk, I would like to say a few words about the changes, the problems that occurred and arose for that mode of explanation, and to bring the story to the present as best as we can. As I discussed in that earlier portion of the talk, the so-called covering law or received view of explanation, which dominated pretty much the last half of the 20th century, originated in David Hume and the 18th century with the problems of causation. At the time, Hume assumed that empirical sensory data were the one taproot method of obtaining knowledge and accessing truth. And what Hume argued was that he never saw, he never observed, he never perceived either the efficacy of causal relationships or their necessity. His argument was that all he ever is able to perceive is one event, A, regularly and contiguously followed by another, B, and that is really what causality boils down to. We have no other knowledge, we have no other access to any kind of causal force or causal efficacy despite our claims to that. So that what Hume effectively does with this move is to remove causality from the sphere of ontological reality and relegates it in the epistemological realm of relationships among concepts or ideas or sensory perception. This model or mode of explanation which Hume launched got its most exquisite articulation in that article by Hempel and Oppenheim, which appeared in 1948, in which the covering law model is spelled out and explanation is argued to be tantamount to an argument. One explains something by providing an argument for it, whereby the conclusion of a deductive syllogism is equivalent to being able to predict the appearance or the phenomenon in question. Because of the way deduction works, you can thereby also retrodict the premises in any syllogistic argument, which immediately causes a problem for our understanding of explanation, because one never assumes that an event explains the laws from which it is derived. Explanation has an asymmetry in the direction of explanation that deduction does not, and that will, as we will see later, poses a problem for our understanding of explanation as derivation. But be that as it may, this was the standard understanding of explanation. And if you want to read a beautiful summary of how this came about and the criticisms in the following 4 decades, his 4 decades of scientific explanation is the locus classicus for that account. The reason I'm playing around with the terms taproot and adventitious roots is that in the earlier portion of this talk, I had described how an explanation was assumed to be able to tap into one correct mode or logic of explanation and thereby give us access to truth. If you think of a taproot, a carrot, as something that makes contact with and penetrates a fundamental ground, then adventitious roots are more like orchids in that they derive their nourishment from the environment. And if you allow me the metaphor, let us think of things like cultures, time, context, traditions, praxis, all of these as being adventitious roots in which human beings are embedded. Well, none of these aspects of life and reality were ever considered to be able to play a part in any kind of mode of explanation. So all references to context were dismissed by the received view of explanation as derivation, while retaining the logical connection between explanation, scientific explanation, and the role of eternal, unchanging, universal, non-phenomenal grounds of explanation. That's one of the reasons why history was never supposed to be a science, was never taken to be a science, because if history essentially incorporates and involves cultures and traditions and time and history and temporal relationships, then because it had to rely on that, it was not considered a science at all. Similarly, science since the 17th century and the scientific revolution reduced wholeness or unity or cohesiveness, what we today call systems or organisms. They were supposed to be no more than just aggregates and thereby tractable by abstract universal laws. The notion that we would be able to explain the emergence of a new ontological systemic level, much less that it would occur, was simply something that was not accepted by this approach to science and explanation. Therefore, because the universal law that played supposedly the role of the major premise in a deductive explanatory syllogism, no ceteris paribus laws could be accepted or admitted into any kind of mode of explanation, because a law that would say all A or B, well, except when these particular circumstances hold, would not satisfy the logic of explanation that was part of the received view. Neither was any possibility of indeterminism. The assumption was that laws of nature were deterministic and indeed strictly deterministic one-to-one, so therefore no multiple realizability could be allowed into the picture, whereby, say, a systemic whole can be carried out or implemented or embodied in any number of different microarrays, so that one could not predict on the basis of the systemic characteristic that one observed which particular microarray was implementing it at that particular moment in time. That was not permitted. The possibility that these laws might be probabilistic or statistical was always supposed to be a reflection of our ignorance, not part of reality. And in particular, the notion of time. Dynamics, in a sense, had gone out of the picture. The fact that time was reversible according to Newtonian mechanics, that was, in a sense, incorporated into a deductive nomological model of explanation, because in deduction one can retrodict as well as predict. When statistics and probability were emphasized as something one could not quite get around, most scientists held to the belief, well, that may be so, but it's only due to our ignorance, not due to the fact that reality is objectively indeterministic or probabilistic. So you have some modifications of the deductive nomological model of explanation, the covering law model of explanation, to include statistical laws, and that was called the deductive statistical model of explanation. A bit later on, even Hempel played around with the notion of inductive statistical models of explanation, but all of them, in a sense, followed the same covering law pattern, and where it was statistical or probabilistic, it was assumed to be due to our lack of ability to, for example, track every single particle in a body of gas, but that in principle it was doable. Now, one would think I have talked about Hempel and Oppenheim's article in 1948, which they then followed with a book with the same name. But one would have thought that with the appearance of Darwin and thermodynamics in the 19th century, that this model of explanation would have been called into question. In the case of Darwin, certainly time is brought back into the picture. You have an evolutionary dynamic that is part of the story of living things and the story of nature. And in the case of thermodynamics, you have the notion of entropy and the reintroduction of the so-called arrow of time. That did not happen, and I'll talk about Darwin in a minute. But logical positivism, behaviorism, eliminative materialism, all of these in the 20th century continued to privilege one language, which many have called, including myself, a physics envy, the idea that it would all, in the end, be able to be explained the way Newtonian mechanics was. Now, relativity theory itself was an issue, but more importantly even, quantum mechanics seemed to suggest that the indeterminism was not just due to our ignorance, that it was due to the nature of reality. But in the case of Darwin, for example, Darwin himself believed that evolution was not an explanation. And the reason Darwin assumed evolution was not an explanation was because of the role of mutation. And the role of mutation meant that these universal laws of nature could be brought down, yes, if you will, because of a random mutation that would then, through selection, become amplified and result in speciations. So the reason why one could not have universal laws of biology would be because of the role of explanation. However, that understanding of Darwin of the logic of explanation has not seemed to prevent, in more recent years, contemporary scientists from explaining, for example, psychological or economic traits by appealing solely to natural selection. So you see the received view of explanation as derivation has nonetheless in practice not been adhered to the way it has been in the literature. As mentioned a couple of minutes ago, in classical thermodynamics, for the first time, the deductive-statistical inference model comes into its own because that is the only way to capture the behavior of gases or the concept of pressure and so on. But nonetheless, the assumption was retained or remained that the characteristics of the systemic level, call that the level at which we talk about pressure or behavior of gases, is due to our ignorance of the detailed goings on at the particle level, not because of any ontological reality that is statistical. Now, there were a number of problems that began cropping up in the 1960s with this inference derivation model of explanation. All of these are chronicled again in Salmon's other book, Causality and Explanation, which I strongly recommend to anyone studying this particular area of science. And that is the problems of deduction and irrelevancies. If you add a premise that is irrelevant, it doesn't affect the deductive argument, but it certainly does seem not appropriate in an explanation that includes an irrelevancy as part of the explanans. Quantum mechanics, as I mentioned a minute ago, did bring indeterminism back with force. No longer did it seem possible to simply dismiss statistics and probabilities as due to our ignorance. The problem of explanation and temporal symmetry seemed to begin to suggest that perhaps the temporal asymmetry that we find in explanation that we don't find in deduction, where you can argue backwards and retrodict as well as you can forwards and predict, that this asymmetry in explanation, A is followed by B, even in a Humean notion of causation as regularity. You don't go arguing backwards that B, therefore A, that is in fact considered to be the law of the fallacy of affirming the consequent. So that seemed to indicate that the reason why this was so was because perhaps there was a forceful, old-fashioned, if you will, cause lurking somewhere. Also, the problem with the deductive statistical model of explanation that I won't say replaced the deductive nomological, but attempted to modify or soften it some, is the question, well, how probable must the conclusion be for one to claim that an explanation has been given? And even worse is the fact that we are often able to explain improbable events. Statistics allow us to explain improbable cases. Well, you know, there is a 10% chance of this happening, so therefore, yes, out of 10 throws, one of them happened to turn up this way. Whereas in the case of deductive statistical models, one would think that only a conclusion with a high probability would be part of an explanation. Now, by the end of the 19th century, according to Wesley Salmon, the consensus seemed to be, which is curious because given the scientific revolution of the 17th century, you wouldn't think that this would be so, but the idea was that science can explain what, and it does so through definition. We talked about the role of definition in the first part of this talk, and it also could explain how. Certain mechanisms of composition in artifacts, for example, how the artifact carries out its function. But the consensus at the end of the 19th century, according to Salmon, was that because science cannot explain the whys, given that science had dismissed formal and final cause from the picture in the 17th century, given that even in a Newtonian notion of causality as billiard ball forceful impact cause, science could not explain why. It could only explain how and what. And according to Salmon, this assumption that science cannot explain why is not accepted any longer, and that is part of the story of how our understanding of what constitutes a scientific explanation has changed in the last century. Again, the problem of causality, though, continues to plague us, because if quantum mechanics brought ontological indeterminism back into the picture, it has really wreaked havoc on the notion of causality. And so Hume would be delighted. See, I told you so. There's no way we can understand causal relationships the way we thought we're able to. Again, these are Salmon's two major works with the bibliographical information. The 1984 one is sort of the beginning of his process of chronicling this trajectory of modes of explanation in science. But what I wanted to do, the reason I included that 1984 book is because Salmon starts asking the question, isn't it time that we put the cause back into our explanations that say the reason why it happened is because X, Y, Z, and Salmon says, isn't it time to bring the notion of cause back into explanation, as opposed to pretending that it isn't an issue at all by resorting to lawful regularities, argumentation, and like. So, beginning even earlier than that, Wesley Salmon starts talking about statistical relevance. That is, it's not just statistical regularities that matter, because there are some statistical or probabilistic regularities that happen to be coincidental, and we know that. It's the fact that these statistical correlations seem to be relevant that matters both in explanation, but also that is what leads us to suppose that perhaps there is a cause lurking somewhere, and in particular that the reason for the correlation, for that statistically relevant correlation, is that there might be a common cause. Even if it's not A causing B, but there might be a common cause C that is responsible for both A and B, and that is the reason why we suspect that there is an explanatory issue between one and the other. So Salmon proposes a new understanding of causality as the transmission of a mark. So if A is related to B in such a way that A transmits a mark to B that, if nothing else is done, continues in effect, we call that relationship causal. Now, one thing that's quite important is to distinguish between causal processes and pseudo processes. And again, Salmon, following Reichenbach, analyzes causality as those processes that may be statistically related to each other, but where one carries the mark of the other, causality is at work. But what I find again very interesting is that in the end, Salmon and those who follow his understanding of causality as mark transmission, which, by the way, Salmon rejected or renounced a number of years later, is that the concept of transmitting a mark ends up being cashed out in terms of efficient cause involving energy transfer. And so we're back to the problem that Hume had before. We never see or perceive that forceful efficacy at work. There was an attempt to get around that by analyzing or cashing out the concept of efficient cause the way Bertrand Russell did as the at model. You know, if at every point along the way the process carries that mark, then transmission is captured in that analysis. But the problem is that most objectors pointed out that this gives a very static, staccato understanding of transmission, and the flow and the dynamical flow of a causal relationship gets lost in the process. So despite Salmon's attempt to bring causality back into the cause and to analyze it in terms of, and to analyze the statistical relevance relationships in terms of cause and cause in terms of mark transmission, you're ultimately back to the problem of we really don't have a good account of causality. Meanwhile, and I think this is probably in the future the mode of explanation that will be most relevant to complex dynamical systems theory, for example, is Michael Friedman and Philip Kitcher separately spoke about what really counts as an explanation is when you provide a unified story or world picture that somehow all the pieces fit. Of course, the problem is, one, how do you define what counts as an independent assumption? That causes all sorts of problems theoretically. how do you explain the fittingness or the fitting togetherness so that you have unification in a worldview or in a world picture? More recently, I am much more interested in, it's not Michael Lang, it's Mark Lang's notion of the role of constraints in a unification explanation. I'll talk about that towards the end of the talk. So there was an attempt to get away from the notion of explanation as derivation. An explanation as unification would not be an argument. You would not have logical relationships of either deduction or induction as you would in an argument. Rather, you start hearing the terms narration, narrative, storytelling appearing more and more into our accounts of what is to qualify as a scientific explanation. Now, it seems to me that enter complexity theory. It seems to me complexity changes everything. And what I mean by that is that the context dependence, the feedback from the environment that is an essential part of a complex adaptive system really changes everything, as does its non-linearity. Where you had linear relationships, you had no problem simply assuming that the whole reduced to an aggregate of the component parts. As soon as you have nonlinear relationships, as soon as you have feedback and what I will argue later is the closure of constraints. I started talking about the closure of constraints as early as 1999 in the book Dynamics in Action. I'm not sure I understood in detail then what it all involved, and I will strongly recommend a forthcoming book by Alvaro Moreno and Mateo Mocio that Springer will come out with this fall called Autonomy, as being a wonderful example of setting out the context dependence over time. How context, I argued, yes, in 1999, includes time and history. Its sensitivity to initial conditions means you're not going to have universals. You are not going to have strict one-to-one determinism. Each run of a complex adaptive system is unique and uniquely individuated over time and becomes more itself an individual, if you will, over time. All of that appreciation that took the ability to model these processes on a computer, given that they are not tractable analytically, all of this, I think, has been the motor that is driving our change in our understanding of what counts as a legitimate scientific explanation. As early as 1984, and I was able to show, I came across Kant's critique of practical reason, the critique of judgment and teleological judgment, that where he himself, even dealing with a Newtonian notion of efficient cause, says to himself, look, this cannot be true for living things, because what's characteristic of a living thing, like a tree, is that the tree produces the leaves, but is in turn produced by the leaves. So you have mereological, bottom up, top down causality, from parts to whole, from whole to parts. And our understanding of cause, and therefore our understanding of explanation, can't fit into this picture. And what struck me as far back as the mid-1980s, when Prigoghine's work became more popularly accessible to the layperson, is that, in a sense, autocatalysis and self-organizing dissipative structures are beautifully able to capture this mereological bottom-up, top-down causality, whereby these recursive dynamics from chemistry on create the boundary conditions within which the higher order system self-organizes, they are able to account for multiple realizability in autocatalytic processes. The autocatalytic function exists, if you will, ontologically at a level of organization independently of the particular catalysts or chemicals that carry that overall systemic function out. And all of this seems to me to play a very big role in our understanding of chemistry, of explanation, and is changing the way we look at it. In particular, the notion of context-dependent constraints as opposed to context-free constraints. Once you have closure of a context-dependent constraint, and the difference is that context-free constraints, I argued, take a system far from equiprobability, but context-sensitive or context-dependent constraints take processes far from independence. They really link and make interdependent processes in a way that once you have closure of these dynamics, you have the emergence, true emergence, self-constructed emergence, not pre-established final formal causes, but the construction of a new ontological level that then exercises top-down control by modulating the processes occurring at the lower level. This top-down causal, yes, I want to call it causal. If you don't want that term because you're married to the notion of causality as efficient causality, that's okay. The modulation from top down does not involve energy transfer, so you don't have the problem of overdetermination. You don't have the problem of violating the law of conservation of matter and energy, and you have a respectable scientific notion of how top down the meta level constraints can cascade down such that the microarray that carries out that meta level implements that final and formal cause, if you will. We now have scientifically respectable understanding of the constitutive aspects of complex adaptive systems that enable us to look at our understanding of explanation in a completely new and different way. I think it was Wesley Salmon also who said that there were two basic forms of explanation. There's the etiological or genealogical, the one that traces the trajectory or the origin and source back to where it came from, where it originated from. And what I tried to do in Dynamics in Action in the book is to point out that, in a sense, the new emphasis on narrative and hermeneutics and storytelling that we find so often nowadays in complex dynamical systems theory is an attempt to go back to that form or format or logic of explanation. According to Salmon, there's also the constitutive form of explanation, which talks about the mechanisms of which that phenomenon is composed. Now, causality kind of straddles both because, in a sense, of course, insofar as you're talking about the background or where it came from, it's an etiological account to give the causal origin or source of a phenomenon that you're trying to explain. On the other hand, insofar as you are showing how that phenomenon is structured such that the systemic emergent properties appear, then you have a constitutive account. And that too I was trying to do, although I wasn't, I think, very clear as to the distinctions between the constitutive aspect or characteristic of the operation of constraint closures that you get with dynamics feedback in particular, and the historicity that these dynamics implicate or constitute. So I think what we have in these new forms of explanation are two kinds of explanations that are going on when you talk about complex dynamical systems, and that is between bifurcations, between speciations, you're describing the historical or developmental, if you will, inherent in the case of human beings, constraints that act as a regulatory mechanism, if you will, that provides a genealogical or an etiological, really, explanation of why the current phase space is what it is within which the system functions. In other words, it explains types or kinds. It doesn't really explain the particular phenomenon itself. For that, I think to describe the current constraints, the particularities of those constraints, the way that the context dependence works in each constraint, that I think perhaps is more akin to a constitutive type of explanation of the dynamics of a phenomenon. And what I am working on right now, although it won't be part of this talk, is to try to account for the problem of qualia and the phenomenal problems in the problem of consciousness, is to try to show how all emergents constitute a new form of cohesiveness, and they come about because of the closure of context-sensitive constraints, but they're not always the same. In Dynamics in Action, I called these context-sensitive constraints, the bottom-up ones, enabling constraints, because they expand a system's phase space. That's what the emergence consists in. And in fact, that new emergent whole, W-H-O-L-E, is embodied in those constraints that simultaneously come about because of the hierarchical differentiation and, in a sense, the creation of a type token distinction. So this is the kind of explanation I think that we would be looking for if and when consciousness does become tractable. And that the top-down constraints do embody and implement this new cohesive emergent levels point of view, if you will. And that is why they act, if you will, on behalf of norms and criteria at the higher level. I want to repeat what I said earlier about a manuscript I just had the distinct privilege of reviewing for Springer, and that is Alvaro Moreno and Mateo Mocio's new book coming out this fall called AUTONOMY. And I think it provides a beautiful model of the logic of explanation that becomes necessary when one looks at phenomena from the point of view of complex dynamical systems theory, because it articulates both the constitutive and the etiological accounts into a unified picture. It does so by showing, for example, how what people like Varela and Maturana call self-organization. In those cases, in the physical phenomenon, the boundary conditions are imposed from outside. But when you get to autocatalysis and the chemical level, phenomena that you can now genuinely call autonomous are such that they, in a sense, have imported the boundary conditions into the recursive and constitutive dynamics themselves. But then when you get to living things and you have a genetic record, what you need is a diachronic account of how the regulatory aspect of this record, which operates top down and decoupled from metabolism, it's not embodied in energy transfers, then regulate, constrain top down, and modulate the metabolic processes that are constitutive of the system. It's this kind of new mode of explanation that articulates, that interweaves both genealogical and historical and etiological types of explanation with a constitutive account that includes causation, but it's not just limited to efficient causation, but somehow through the operation of context-sensitive constraints and constraint closure can account for new complex dynamical systems. So I think we're at the dawn of a new kind of logic of explanation and mode of explanation that will be able to account for wholeness, for unity, for cohesiveness, as well as for context sensitivity and dynamic feedback and embeddedness in the environment. Thank you very much.